Okay, so we were looking for a question to solve. We are looking for a question to solve. And that one I found it in on page 31. You go to page 31. There is a question of May 2017. It's a question of May 2017. Question 2B. And we answer Roman 1. Question 2B, Roman 1. So Patrick, you can read for us. You're there. Yes.
Machines that operates 24-hour cycle. The probability of a machine breaking down for any given day is 0.015. Required. The probability that exactly 4 machines break down in a given day using Poisson distribution. The probability that exactly 4 machines break down in a given day using binomial distribution. Moment of the results obtained in B11 and B12 above.
Thank you, that's good. So I think the first thing that I need to show you is there's a card somewhere there. Getting E in the calc, in the calculator. You want to get E in the calc. So the first thing is locate E raised power x on the calc. On the calc. Then press shift. Then press EX button. This button is IN. Looks like IN. So track it. Check whether you can see that button. Are you able to see it? So if you are able to see it, then you press shift and that button, you have E on the screen. So if you need the answer, if you need to go to this one, then you press 1 and then you press equal. So press 1 and then press equals. Are you getting this? Yes, that's how you get it. How you get it. How you get it. The next thing now, we are back to our question. Back to our question. We already know this formula. In using this, or when you're dealing with this probability distribution, you have 2 ways. You can either use E as a number, so you have to go all the way to the end. Or you can just stop at this point and proceed with E being in the calc. That is what I would want us to be doing. So in most of our cases, so what we need then to identify is the mean lambda. which we have said is the mean. Now, this question has not given us the mean, but we know from our other studies, the mean, which is x bar, is given as sum of the xi's you multiply by the probability of xi. That one we know from other studies when we are looking at descriptive statistics. We are looking at descriptive statistics. So what now you need to do is our n is 30. There are 30 machines, and the probability of a machine failing is 0.015. 0.015. Uh-huh. 0.45. So when you are told exactly 4 machines, when they tell you exactly 4 machines, they mean that x is 4. They mean that x is 4. So if they mean that x is 4, the probability of 4, of x being equal to 4, will then be equal to e raised to power minus 0.45 multiplied by 0.45 raised to power 4. You divide by 4 factorial. By 4 factorial. Sasa, chukua calculator and make sure you follow instructions. Chukua calculator and make sure you follow instructions because I may not be able to repeat. Press shift, then press E. Now you have E on the screen. Now press open the brackets. Then press minus 0.45, close the brackets, then same at times 0.45 raised by 4, so press 4, then press divide, press 4, then press shift, then press the button ilikuwa na factorial where you had seen x factorial, and then press equals. You have 1.0 something raised to power 0 minus 0.3, yeah? So that means the answer is 0.00. Ukiona imereisiwa to power minus 3, unaandika 2 zeros. Kama it is raised to power minus 5, unaandika 4 zeros. So 0, 0, 1, 0, 8, 9. Unaweza iachia hapo. So that is how simple it is if you have mastered the use of the card. Let's look for another one. Which is on page 28. On page 28. It is a question that was tested in May 2018. May 2018 as question 5A. As question 5A. So Sarah, if you are there, you can read for us.
I mean, positive company and established that the limited number of occurrences of vetting and striking transformers follows a Poisson distribution with a mean of 0.4 per week. Required that when we have the probability that no transformer will be struck by lightning in a week. We can see the probability that at most 2 transformers will be struck by lightning in a week.
Thank you, that's good. So obviously the first thing is to write the formula, but we are not writing because it is just here. That is the first thing, we always write the formula. The next thing, identify your, you see this E, this one you get it from the calc, so you don't need to write it again. But this one you need to identify in case there is any computation required. So Rabda, tumesema it is the mean, and the question says the mean is 0.4. The mean is 0.4. So when the question tells you the probability that no transformer, so when they say no transformer was struck, they exactly mean that X is 0. That bit is very, very important to be understood. They exactly mean that X is 0. So the probability that X is 0, the probability that X is 0, using this formula that we have here, we are going to say E raised power minus 0.4 multiplied by 0.4. You raise power 0, you divide by 0 factorial. You divide by 0 factorial. So chukua calculator tutembee pamoja tena. So tumesema you press shift. Then after you press shift, you press E. Open the brackets. Then you press minus 0.4. Close the brackets. Then you say times 0.4 raised to power 0. Then you say divide 0, shift factorial where we had seen X factorial, and then you say equals. Are you getting 0.67032? Yeah. That is how it is supposed to be done. Now for your assignment, oh, hatujamaliza hiyo. Sorry. Well, there is a lot you need to handle today. That's why. Hatujamaliza hiyo swali. So hiyo ingine ilikuwa nasema the probability that at most 2. So if you are told at most 2, transformers, at most 2 transformers. What do they exactly mean? They mean that X, when you see the word at most, it means that value or less. So it means you can take 0, or you can take 1, or you can take 2. That is the meaning. When you see the word at most, it means that value or less. Sasa, the probability of X being 0 or 1 or 2 will be equal to, we put in the calc or this one we already, but we can just put kila kitu. E raised power minus 0.4 multiplied by 0.4 raised power 0. You divide by 0 factorial. Then you say plus E raised power minus 0.4 multiplied by 0.4 raised power 1. You divide by 1 factorial plus E you raise power minus 0.4 multiplied by 0.4 raised power 2, you divide by 2 factorial. So you can either solve independently or zote pamoja. So because hatukuwa tumerab hii ya kwanza, hizi itakaa okay? So sema plus, then tunarudia to the same step. So sema shift E, open the brackets, minus 0.4, close the brackets, multiply 0.4 raised by 1 divide 1 shift factorial. Aya, sema plus. Aya, ukisha sema plus, tena unasema shift E, open the brackets, minus 0.4, close the brackets, then we say times 0.4, you raise by power 2, then you say divide by 2, so press 2, then press shift and press factorial, then press equals. Check whether you are able to get 0.99207. Kama hujapotea, that is what you should get. 0.99207. Okay. Sasa hiyo, that now brings me to where I was saying I need to give you an assignment. I need to give you the assignment. So we are now dealing with the assignments. So the first one is on page 17. There is a question of November 2019. Question 1B. Question 1B. I think here, that's the one that's there. Let's go to the next. yenye inaitwa binomial. Binomial probability distribution. Binomial probability distribution and we write that this is used where the following characteristics exist. This is used where the following characteristics exist. The following characteristics exist. One is the experiment relates to a discrete variable. The experiment relates to a discrete variable. Number two, the experiment has only two possible outcomes. The experiment has only two possible outcomes. Full stop, but still on the same point, write that the desired outcome is labeled success. The desired outcome is labeled success, while the other outcome is labeled failure. While the other outcome is labeled failure. It's labeled failure. Number three, the probability of success, brackets P. The probability of success, brackets P, and the probability of failure. And the probability of failure, into brackets Q. Brackets Q remain constant. Remain constant in all the trials. Remain constant in all the trials. Full stop, alafu andike P plus Q is equal to 1. Q plus P is equal to 1. Number 4 now. Should be number 4. Character number 4. Because number 4 is that the trials are independent of each other. The trials are independent of each other. Okay, then down there, wadike. The formulas used are probability of X is equals to N combined X, P u raised to power X, Q u raised to power N minus X. They ask for the mean is given as NP. If they ask for the variance, They ask for the variance. It is given as NPQ, where X is desired number of successes. Desired number of successes. Desired number of successes. N is trials. Number of trials. I think kila kitu kingine tulikuwa tumesema. We already know P, we already know Q. Hiyo swali nimeiona. Hiyo swali tumejibu, that was on page that one. Page that one. Which was a question of May 2017. May 2017. Question 2B. Now we are answering Roman 2. Now we are answering Roman 2. So that question already we have read. So straight on. Again, when they say, or first of all, you need to know N is what, or before you say even N, before you even say N, the question is asking us to get the breakdowns, the probabilities of breakdown. So you simply say, let success to be the breakdowns. Success to be the breakdowns, because the question is asking us to get probabilities of breakdowns. Then P is the probability of our breakdown, which is already given there, 0.015. When we are given that, it then means that Q will be 1 minus 0.015. Q will be, because when you add them, it should give you 1. .985. N is how many machines are involved. We have 30. The other thing that you need to identify is when you are told exactly 4, that means X is 4. X is 4. So the probability of X being equal to 4. We already have our formula here, so we are not going to copy again. We just substitute. So N is 30. Combine 4 multiplied by P, which is 0.015, you raise power 4, multiplied by 0.985, you raise to power N minus X. So hii inakuanga hivi, 30 minus 4, that will be 26. That will be 26. So let's take the calc. We know where to get the combinations, what you are doing. So sema 30 press the button where your combination is, then press 4. So on the screen now you have 30 combined 4. Then tuendelee tu sema times 0.015 you raise to power 4, then you multiply by 0.985 raised to power 26, then you say equals. Now kuna error. 30 combined 4 multiplied by 0.015 raised to power 4 multiplied by 0.985 raised to power 26. Are you getting times 10 raised to 74? Kwani yangu ina sini 30 combined 4 times 0.015 I raised to power 4 times 0.985 raised to power 26. Or you are getting times 10 raised to minus 0.4. So ukiwa na minus 4 utaandika 3 zeros. That's what you have said. So itakuwa 0.0004547. Okay, so that is how it's supposed to be done. Ile jibu tulikuwa tumepata kwa horizontal ilikuwa what? Tulipata nini? 0 points. We solved this question to me horizontal. Was very fast. 0, 0. How many zeros? 2 or 3? 2. 1, eh? Okay, something like that.
No.
I put 1. Yeah. You can see there is a slight difference. That's okay. Because the methods are different. Let's go to another one. That is page 46. Page 46. Yeah. Page 46. There is a question that was tested in December 2014. December 2014, and it was tested as question 5B. It was tested as question 5B. Question 5B. So now, a survey was conducted in Pamoja village to establish the proportion of households that were affected by a certain pandemic. The results indicated that 40% of the households in the village were affected by the pandemic. A sample of 6 households was randomly selected from the village. Required those probabilities. So the first thing you can see, this one is a discrete variable because we are dealing with households, and you cannot have a household that is half. You only have a household that is complete. The other thing is you can see there are only two possible outcomes. It is either uko mgonjwa ama hauko mgonjwa. Then we are given the probabilities. So the first thing we will come here and say, rate success to be affected, those who are affected. Success is affected. Then P, the probability that a household is affected is 0.4. 40% of households are affected. Q will then be 1 minus 0.4, which is 0.6. 0.6. N is how many households we are dealing with. We are dealing with 6 households. We are dealing with 6 households. Now, the other thing that we need to get is X, but X now depends on the question that has been put across. So the first one is only one household. I want to approach it this way. So when you are told no household, hakuna swali kama hiyo hapo. No household, it then means that your X is 0. It means that your X is 0. So the probability that X is 0 will be 6 combined 0 multiplied by 0.4 raised to power 0 multiplied by 0.6 raised to power. Tumesema you subtract here 6 minus 0, you get 6. Kwa calculator tuseme 6 combine 0 times 0.4 raised to power 0 times 0.6 raised to power 6. Are you getting something like this? 0.046656? Good. Those who are online, I hope you are following and getting those values. Higher. One household. They are saying only one household. So when you are told only one household, it means that your X is 1. So the probability that X is 1 will then be 6 combined 1 multiplied by 0.4 raised to power 1 multiplied by 0.6 raised to power 6 minus 1, which is 5. 6 minus 1, which is 5. So we go 6 combined 1 multiplied by 0.4 raised to power 1 multiplied by 0.6 raised to power 5 equals, you have 0.186624. The next question they are saying, exactly 2. So if you are told exactly 2 households, exactly 2 households, that means X is 2. That means X is 2. So probability that X is just 2, it is 6 combined 2 multiplied by 0.4 raised to power 2 multiplied by 0.6 raised to power 6 minus 2, which is 4. Which is 4. So sasa hiyo itakuwa 6 combined 2 multiplied by 0.4 raised to power 2 multiplied by 0.6 raised to power 4. And I'm getting myself 0.33, no, 31104. Huyo mwingine wanasema at most 2. At most 2 households. At most 2 households. So when you're told at most 2 households, it means that X is either 0 or 1 or 2. That is the meaning. So kama namna hiyo, we already know. So the probability that X is 0 or 1 or 2. We already have those answers here. So we just copy them as we add. That is 0.04 6656 plus 0.18 6624 plus 0.31104 186624.046656 equals 0.5442. Finally, we are told 3 or 4 were affected. So 3 or 4 households. The meaning of that is that X is either 3 or 4. 3 or 4. So sasa hii itakuja useme probability of X being equal to 3 or 4 is equal to 6 combined 3 multiplied by 0.4 raised power 3. You multiply by 0.6 raised power 3, because of 6 minus 3, plus 6 combined 4. 6 combined 4 multiplied by 0.4 raised power 4 multiplied by 0.6 raised power 2. We still do the same thing, yote tunaweka kwa calculator. So tutasema 6 combine 3 times 0.4 raised power 3 times 0.6 raised power 3 plus 6 combine 4 times 0.4 raised to power 4 times 0.6 raised to power 2. Unasema equals. Are you getting 0.41472? Good. Those who are online, are we together? If we are together, type yes. Yeah, good. You can see the yeses. Yes, I can see that. Okay, so I can see the yeses from 5 people, 2 people have not responded. No, actually 1 person. Good. Haya, sasa ile assignment niliwapea kwa Poison iko mpaka na binomial. So as you do it in Poison, you also do it in binomial. You also do it in binomial. Huyo mwingine sasa anaitwa exponential probability distribution. Exponential probability distribution. Now this one, it can be used in many areas. And because we cannot write all those very many areas, I want to summarize it this way. This is used in a question. This is used in a question where the word exponential has been mentioned. In a question where the word exponential has been mentioned. The computations are, or the formulas used are, probability that t is greater than or equal to t small is e raised to power minus u t. Probability that t is less than or equal to t 1 minus e raised to power minus ut. Then probability that t is less than or equal, we are here t1 here, capital T2 is e raised to power minus ut1 minus e raised to power minus ut2 where t small is desired time, u is given as what? Out of mean service time. So this one is more used in a topic that they have already removed from your syllabus. I think even this one they forgot to remove, should have removed it. Because it's more used in a topic we call queuing theory. Queuing theory is a topic we study things such as when you go to the hospital and there is a queue, how long will it take to be served? When you are going home and in your bus stop there is a queue, how long will it take? When you go to the hotel and you place an order. So you might have if you are the owner of the hotel, how many cashiers do you employ? If you are the owner of the bank, how many tellers do you employ? Hiyo maneno yote ilikuwa kwa topic tulikuwa tunaita queuing, but walishaamua. So I will therefore just give you an example. think that will be good enough. After all, we have the formula na sasa maneno ya hii tunajua, si ndio? So, look at example 1. Example 1. In a certain hotel, an order takes an average of 10 minutes. An order takes an average of 10 minutes to be delivered to the customer. An average of 10 minutes to be delivered to the customer. If the service time is exponentially distributed, if the service time is exponentially distributed, what is the probability that? What is the probability that an order will be delivered? An order will be delivered, semicolon, Roman 1. After 15 minutes. After 15 minutes. Number 2, within 6 minutes. And Roman 3, between 12 and 18 minutes. Between 12 and 18 minutes. So solution to that. The first thing that you do is to identify your meal. That's a joker. But I still have 1 hour. One hour and one more distribution meal. Okay, so meal is 1 out of the service time, so the 1 out of 10. So Roman 1, it is probability that T is greater than or equal to 15. So this is E, you raise power minus 1 out of 10 multiplied by 15. So get your answer there. Then huyu mwingine, probability that we are less than or equal to 6, it is 1 u minus E, raised power minus 1 out of 10 multiplied by 6. Get your answer there. And then probability that we are between 12 and 18 is is E raised power minus 1 out of 10 multiplied by 12. U minus E raised power minus 1 out of 10 multiplied by 18. So get those answers the way you are solving using Poisson. And then we take a break of 5 minutes. So I'll be back 12:15. We have to agree the last distribution.
Sasa wacha nikuulize, ile ni T ama ni one is greater or less than one? Kama ni T ama ni one?
Probability of T is less than T ndogo. Hiyo ni T, kuna T kubwa na T ndogo.
So hii T kubwa ni in which one of which? Because sasa hiyo you need utatumia utaiweka ama utaiandika tu. Ama ni
So you have the answers. What do you have? Nisome hapa. 223 13. Are we agreeing with that? Those who are online, if we are in agreement, say my yes. The next one, 4 5 1 1 8 8. I can see what all right. And the last one, 1 3 5 8. Good. So let's now look at the last one, normal probability distribution. Normal probability distribution. Normal probability distribution, and we write that this is used where data has a mean of 0. Data has a mean of 0. And a standard deviation of 1. And a standard deviation of 1. It is still applicable. It is still applicable. Even where the mean is not 0. Even where the mean is not 0. And the standard deviation is not 1. The formula used is Z is equals to X minus X bar divided by standard deviation. Z is equals to X it is illustrated as follows. Is illustrated as follows. Standard deviation is 1 and X bar there is 0. So the whole of this is 0.5 and the whole of this is 0.5. Now, for those who are online, there is a table that was sent yesterday. It's a table that was sent yesterday. You can imeandika document 39 PDF. That is a table. Those who are physical. Those who are online, can you confirm that you have seen the table?
Yes.
Good. Now that table, it is just the one that is in your past papers. In your past papers, look at your past papers on page 57. Page 57. On page 57. It is the same. The only problem with the one in the table, in the papers, these titles of the columns, hazikupangwa vizuri. They are supposed to be 1, 2, 3 mpaka 9. Lakini ikianza kufika number 4, the alignment is not done well. Not done well. Eunice, make sure you mute yourself unless you're talking. Good. So tuko sawa, Good. So kama tumeiona, those who are online, in case you want to speak, you can unmute yourself. I don't think I've restricted. Let me confirm. Yeah, I've not restricted, but immediately you. Sasa, this number is the most common. And I want to illustrate. I hope the time that is available will allow me to finish. It's good. Andika illustration. In a certain company, salaries are normally distributed. Salaries are normally distributed with an average of 30,000, with an average of 30,000, and a standard deviation of 5,000, and a standard deviation of 5,000. What is the probability? What is the probability that the salary of a particular worker, is semicolon. So tutakuwa tunaandika hiyo na tunajibu, Yeah. So the first one, below 18,000. So tunaandika hivyo na tunajibu. So if you are told it's below 18,000, the first thing we kwanza ningewapea Ushaandika Roman 1. Andika ikiwa Roman 1. You are not confused. Roman 1 below 18,000. Roman 2 above 27,000. Roman 3 between 22,000 and 38,000. Roman 4 above 34,000. Roman 5 between 32,000 and 46,000. Okay. So I think that is okay. So now we can have solution. Solution. So in the solution, we start with the first one, below 18,000. So below 18,000. So quickly unachora katepo kadogo tu namna hii. That way. Hii rudi hapa will modify same illustration 1 so that I remember to give you another illustration. Sasa ukishachora hivyo, the mean inaekangwa hapa x bar. This is 30,000. Na hapa standard deviation inawekwa hapo 5,000. Sasa hii ni namba 30. Ukiulizwa 18 iko side gani? Hapa 30 ni hapa on the lower side. So unakuja una mark somewhere here. This one you call it x1, 18,000. Then we shade the area of interest. The area of interest. The area of interest is when you are told below here, these are the ones. So you shade. That is the area of interest. Sasa after that unakuja hapa unaandika Z1 is equal to x1 minus x bar. You divide by standard deviation. So this will be 18,000 minus 30,000. You divide by 5,000. Calculator and give me the answer. Negative The values of Z are given to 2 decimals, so it is exactly 2.4. Okay, so it is written as 2.40, negative 2.40. Then you now tell us probability that X is less than 18,000. It is 0.5 minus. Chukua your table sasa. Your table. Now here table, as you can see, it has 3 types of values. Kuna hizi zimeandikwa hapa za kuteremuka kwa rows. 0.0 zimeenda mpaka 3.9. Simeziona? Hizo ni the first decimal. Value of Z to 1 decimal. Alafu hizi titles za columns. Hizi kina 0 all the way to 9. Those are the second decimal places. Sasa ukitaka kusoma, you go to, tukitaka kusoma ile 2.40, utaenda kwa 2.4, line ya 2.4 hapa. Alafu column 0. What is there? We have 0.4918. Hivyo ndio inasomwa. But something else, 2 other things that you need to note. This value is negative, but the table has no negative value. So ukipata positive ama ukipata negative, unasoma the same way. Utaona tutatumaliza hizo swali utaona. The second thing is this. When you read this value from the table, it will always give you the probability between the interval. Naona hapa easy. Between 18 and 30. So hiyo probability hii tumepata ni kutoka hapa mpaka hapa. Hiyo hii. But tunaona si yenye tunataka. Tunataka hii iko huko chini. But tunajua kutoka hapa katikati mpaka mwisho ni 0.5. So sasa unasema 0.5 minus hiyo umesoma, so that now you get your answer. Zero point 0082. That way. Good. It is okay. Okay. Haya. Wende kwa huyu mwingine. Above 27,000. If we are told above 27,000, so if it's above 27,000, unakuja unachora your katibu again. This way. Hapa unatuambia ni standard deviation, which is 5,000. Alafu mean inakuanga hapa katikati. X bar is 30,000. 27 bado iko on the lower side hapa. So this is X1, which is 27,000. Aya, sasa ukiwa hivyo, you shade your area of interest. When you are told above 27, tunataka wapi? The upper side, the whole of it. So you are going to shade the whole of this. After that, let's now get our Z1 as X1 minus X bar to divide by standard deviation. This is 27,000 minus 30,000 you divide by 5,000. 0.60 negative. So let's go to the table so that we say probability that X is greater than or equal to 27,000. Sasa angalia hapa. Tutapofika kwa tables, the probability that we shall get will be the probability ya kutoka 27 mpaka 30. Lakini unaona, we still require even this other side, which we know is 0.5. So let's start by reading this one first. Nisome 0.60 2258. Alafu sasa uongezee 0.5. So that you tell us it is 0.7258. So my you are 0.6. Sawa? Sawa. Sawa. Okay. Haya, tuende kwa huyu mwingine that says between 22 and 38. Between 22,000 and 38,000. So he again X bar is 30,000. Standard deviation is 5,000. So 22 iko hapa chini. So this is X1, 22,000. Alafu 38 iko hapa. X2 is 38,000. So we want this region. So we shade this. So with that, we come and get our Z1 as X1 minus X bar, you divide by standard deviation. So this will be 22,000 minus 30,000. You divide by 5,000. Negative 1.6, 1.60. Then Z2 is X2 minus X bar. You divide by standard deviation. So this will be 38,000 minus 30,000. You divide by 5,000. That is 1.60, right? Yeah. So you can see now a positive value has come up. Sasa tukienda kwa table kusoma hii ya 1.6. It will be the probability kutoka 22 mpaka 30. Na huyu wa 1.6 hivi takuwa 38 mpaka 30. So how do we get our desire? We add them, see? Yeah, we add them. So probability that we are between 22,000 and 38,000. And nisomea hii ya 1.60 0.4452. So you add another one, 0.4452. So the answer must then be 8904. 8904. All right, let's go to the next. Above 34,000. Above 34,000. So if you are above 34,000, the mean 30,000. Standard deviation is 5,000. So 34,000 this is x1, 34,000. So if we want a bar, so Z1 is x1 minus x bar. You divide by standard deviation. So this is that 4,000 minus 30,000. You divide by 5,000. 0.8. So probability that x is greater than or equal to 34. Now, as I told you, this 0.8 will give us the probability kutoka 34 mpaka 30 hapa. Lakini tunataka hiyo iko juu. So then we will have to say 0.5 minus nitasoma ya hapa. Isome 2881. Zero point 2719. The last one is between that 2 and 46 now. So again, we do our table. This is X bar, which is 30,000. This is X1, which is 32,000. This is X2, which is 46,000. So tunataka hii ka interval hapa na standard deviation is 5,000. So sasa Z1 will be X1 minus X bar divided by standard deviation. So this will be that 2,000 minus 30,000 divided by 5,000. 0.4. Z2 is X2 minus X bar. You divide by standard deviation. So this is 46 minus 30,000. You divide by 5,000. Hmm? 3.20. So the probability that we are between that 2,000 and 46,000. Sasa tutaanza kusoma hii ya 46 because hii ndio imeanza huko kwa 30 mpaka 46. So nisomee hii ya 3.2. 0.4993 minus tusome hii ya kutoka 30 mpaka 32 hiyo ya 0.4 55 4 0.2939. Still have 12 minutes. Sasa andika illustration 2. Illustration 2. Suppose the company in Radika. Suppose the company in illustration 1 above. In illustration 1 above has $10,000 workers. Has 10,000 workers. Semicolon, point number 1. How many workers? How many workers have a salary of between that 2,000 and 46,000? How many workers have a salary of between that 2,000 and 46,000. Roman 2. What will be the salary amount? What will be the salary amount the salary amount below which below which below which 26% of the workers will be found. 26% of the workers will be found. Yeah, so I think those are just to illustrate what happens. So solution. So the first one is number of workers. So the workers. So for the workers, you can just put it that way. Tunaulizwa tujue the workers whose salaries are between that 2 and 46. So the probability of between that 2 and 46,000 is 0.2939. So the workers between that 2 and 46,000 This is what I told you earlier on. Ukiambiwa uhesabu, this is also a way of counting. Ni watu wangapi wako na mishahara ya hapo? So it is simply the probability 0.2939 multiplied by all the workers. The company has 10,000 workers. Yeah. So that gives us 2,939. So that tells you any other number unaweza ulizwa, you just get the probability multiplied by the total. Yeah, that way. The last one, which is now the reverse, is unaulizwa the amount. So kama unaulizwa amount, unakuja hapa kwanza. Unatengeneza your normal table. Your normal table. Unatuambia hii tunajua that the mean is 30,000. And the standard deviation is 5,000. So wale watakuwa chini wako somewhere here. X1. Sasa hii ndio hatujui, lakini tunaambiwa hapa hii yote lazima ikue 0.2, tunaambiwa 26. So hao ni 26. Sasa ukijua hiyo, going by ile ujuzi sasa tumepata, tunajua vile vile hapa it must now be 0.24. Ndio zote zikuwe 0.5. So you ask yourself, Z1 is X1 minus X bar, you divide by standard deviation. If we know that, how do we get x1? If you make x1 the subject of the formula, utapata x1 is x bar plus z1 standard deviation. Just copy that. If you make x1, because x1 is tunatafuta. So you tell us from the tables, Z1 equals haya. Ukiangalia hiyo mahesabu yote tumejibu, anytime x is on the lower side of x bar, it will be negative. And anytime you are on the upper side, it will be positive. So what we are going to get will be negative. And the other thing is this value here. Naona hii tulikuwa tunasoma kwa nini. Sasa tutaingia huku ndani. Unaingia huku ndani. Unatafuta 0.24. You can get it exactly or you may not get it exactly. So what tutafuta 0.24. Haya, mahali naiona hakuna 0.24, naona 0.2422. Anisi tuko ndani. So unachukuaga either slightly higher or slightly lower. So you can also work with hiyo iko chini kidogo ya 2389 Sasa unaona hiyo ya 2389 imebakisha 11 ndio ifike 4. Na hii nyingine imepitisha na 22. So you can pick any. Sasa tukichukua hiyo ya 2422 unakuja hapa kwa line hii kwa row unaipata iko kwa 0.6 na kwa column ni 0.5 so it is 0.65. 0.65. So it then means that our x1 will be the mean, which is 30,000 plus minus 0.65 times standard deviation, which we know is 5,000, times standard deviation, which we know is 5,000. $26,750. So that is how you go about it. That is how you go about it. Now for your assignment, you can try this question that is on page 47. It's a question that was tested in May 2014. As question 2B. As question 2B. And then on page 35, you have a question that was tested in May 2016 as question 2B also. So we call it a day at that junction. And I hope you saw the new timetable. So we are meeting tomorrow. QA is now tomorrow because of the change that we had in economics. So we meet tomorrow to pick up from there. Thank you so much. Yes.